To this afternoon's webinar on KUKA Compose. So today's topic is KUKA Compose, which is our online web tool to actually select the right robot for your application. So based on your input of required reach and payload, the system will then suggest a number of robots that will fit that scenario. After that, you could also put in your load data, both secondary load and any load you want on your arms. And the system will then calculate the loads and see if your application fits for that scenario. When the payload analysis is done and you're satisfied, you can also produce a report out of the system and save it as a PDF file, which I myself have through the years found very useful as to document why did I choose this robot and not another one, because that's easily forgotten a couple of months into the project. Now, KUKA Compose is a part of my.KUKA. That means that it requires a login to a KUKA, to my.KUKA. And if you're not a member there already, please sign up on the point not a member, and you will get a login for your own. So before we start any live testing of this KUKA Compose, are there any questions? Nope. So I'll just switch applications here. And you find KUKA Compose at compose.kuka.com. And if we already have a login, we just at my.KUKA, we press here. Log on with your credentials. And you get right into the KUKA Compose. Excuse me. Now, the first thing I need to do here, because with the filters this wide set up, it will basically show us all robots which are in the KUKA catalog. So let's start limiting our application a little bit. So I can do this either by typing in distance directly here, or use a slide, the slider, to bring down the application. And in this little example I'm planning to do, let's have quite a small robot application. Now you can see the number of robots were 103 before, and it's now down to 15 based on my selections here. I can also put in some further selections, that is mounting position of my robot. If it's a floor mounted, a ceiling mounted, a wall mounted, or even angle mounted. I'll keep it right now as a floor mounted robot. And I can also already here enter if this robot is intended for any special application, for example, a foundry application or a food application. It will then select the robot based on these applications. Now, as you've seen, I've put my load range quite wide yet. And what I'm going to do now is I'm going to actually pick a few robots which I find potentially interesting to use in my application here. So I will, let's take the let's increase the reach a little bit so we can. I will take the KR6, which is potentially what I would like to use. Perhaps a KR8. And no, let's have a KR10 instead. So we get a range and a KR16, for example. Now I've chosen 3 robots, which is the maximum that I can try for. And now I press the button Run Analysis. I choose which is the lead robot here, so to speak. And I now get to a screen where I can enter my payload data. And the first thing I want to do is that obviously my robot will have some kind of gripper or a tool. So I will actually put in the weight data for that one here. I guess this weighs 4 kilos. And its center of point of gravity is a bit out from the flange, obviously. And I'll make it easy for myself and change this to 100 millimeters in the X, which is down from the flange, and 100 millimeters on the Z-axis, which is out from the flange. And as you see, every time I change my input here, the system recalculates the payload data and does a load evaluation in each case. Now, obviously, I don't only have a tool on my robot, but at the end of the day, a workpiece or a payload as well. So I will add a payload here, which I could then call workpiece, for example. And this part weighs 3 kilos, 3.5 perhaps kilos. Its center point of gravity is still 100 millimeters down from the flange, but obviously it's a little bit further out than the tool itself. So let's just, for example, put in 200 millimeters out on the Z-axis for that case. And I'll just add the payload data. And as you see here now, the payload is recalculated to a sum of 7.5 kilos. And if we close this window and go back to the load data evaluation, we've now gotten a couple of scenarios for these 3 robots I selected. So for one of the robots, it actually states that it's invalid. We are way off in the payload data for this robot here. And it's also overloaded on the dynamic side for the KR10 in this case. Although we can see here that the payload is actually inside the curve for the static load. There is one more payload data which we can play around with, and that is supplementary payload data, which is basically any payload mounted on the axis themselves. And here you see that we have one of my old data lingering here, which is 10 kilos. That's probably a bit high, so let's play with, it's only 4 kilos. But you see that, and we can do that for the separate 3 robots. Let's do it, make it very simple for ourselves. That's the same payload or the extra load for each robot. Now what we see here is for the KR6, it went from out of spec to overloaded because a 10 kilo load on the 3rd axis is not really allowed on this one. But still it remains overloaded. The weight is a bit much for this one. And here we see the loads for the 3 robots and the loads on the separate axis for them in a static load. And here we can clearly see that for the KR6 we are overloaded. If we now look at the dynamic loads, we can see that the same thing is actually happening for the KR10 on axles 4, 5, and 6. So at the end of the day, although the load is inside the specs of the KR10, we should consider moving up an application, or perhaps go down in speed quite a lot, because then of course the dynamic forces would decrease. And wise from this morning sessions, we should point out that this tool is not a cycle time application, and the dynamic loads are calculated default out of us trying to move the robot on maximum speed. So in this case, the KR10 still could be a useful robot if we don't have needs for a very short cycle time of the cell. If we can run the robot slow, obviously the dynamic forces would fall down and perhaps be applicable in this case anyway. This is something that we can't simulate or evaluate here in KUKA Compose, but instead should move on to KUKA Simulate to do this application calculation. Now, if we are happy with this scenario here, we can now generate a report based on the data we've inputted here. That's by just putting the export report. It will create a load analysis PDF where we basically see the same sign and the same information we had on the screen earlier. And we can obviously then save this to our project so we can keep this documented, that this was the basis for our choice of robot. And in this case, we would probably have chosen the KR16. Any questions on this so far? Nope. I'm obviously much more clearer than I was this morning. What this basically covers what KUKA Compose does for you. The only recommendation I can make is to log on to the website and play around with the tools so you get a little bit feel for the software in question. There is, in the menu up here, a getting started guide on this, which goes through the Compose tool step by step, explains what each fields are and how you should interpret the report that you get out. So play around with the tool, read together with the getting started documents. That is the absolute best tips I can give you to get a feel of this. This is also a cloud-based software, which means that you could use it from any web-based platform, from your PC, your notepad, or iPad, or even your phone, if you like. So this is a tool you can carry with you wherever you are, in any case. And before I leave you, please get back to me with any suggestions of any changes or wishes or questions. We are here for you. And before we leave you and say thank you for your attention, we just want to promote our upcoming webinars. We have 2 more coming this week, which is for KUKA Expert and KUKA Gripper Spot Tech. And we are continuing our webinar sessions into next week to start off with, at least, with these topics you see here. KUKA Safe Operation, Easy HMI, KUKA IonTech and KUKA KR80, which is a new family of linear robots. But the schedule you see here can be found on the KUKA Nordic LinkedIn site as well. So if you don't have any more questions. We got a question here. Does it come as an app? No, it's not an app. It's a web-based page. It's cloud software, so you don't have to install anything, neither on your computer nor your phone or your iPad or whatever. But you need to have an internet connection, obviously.